Good day, my name is Valentin Kozlov. I am a researcher at Karlsruhe Institute of Technology, and it is my pleasure to present to you our work and the poster entitled Deep Framework for Deep Learning. I also want to thank the organizers of IEC 2020 Digital for giving us this opportunity. The Deep Framework is developed within a European project named Deep Hybrid Data Cloud, one of the Horizon 2020 projects. DEEP stands for Designing and Enabling E-Infrastructures for Intensive Data Processing. There are 9 academical and 1 industrial partners in the project from various countries across Europe. The main goal is to prepare a new generation of E-infrastructures to support deep learning and exploit very large data sources. With our framework, we want to ease and lower the entry barrier for non-skilled scientists, whom we consider our primary users, such that they have transparent execution on E-infrastructures, can build and share their applications via an open catalog or marketplace, profit from the DevOps approach. The Deep platform has 2 software releases. The latest one, called Rosetta, appeared in February this year. In the next slides, we present the latest features of the platform. The key features from a user point of view are shown here, and they include Deep as a Service API, which allows scientists to expose their applications through an HTTP endpoint, delivering a common interface for machine learning and deep learning applications. Deep Open Catalog hosts ready-to-be-used applications and allows to share new ones. It is a central knowledge hub for machine learning applications. From there, one may also deploy modules via the dashboard, on the pilot testbed, leveraging cloud or HPC resources. It is as well possible to exploit modules for prediction and inference via the serverless approach based on OpenWhisk. Now, as a short demo, we show the Deep Open Catalog with various applications hosted here, and if we pick up, for instance, one, we see a general information about the module. We can access the source code at GitHub and the corresponding Docker image. We can also access the web user interface through the serverless approach and do the prediction on the module. And if we want to do the training of the model, we go to the training dashboard, but for that one we need to provide credentials first. Finally, we also provide DevOps approach for our users, where we offer structured development based on the cookie cutter template and continuous integration and delivery pipeline from Jenkins. The final artifacts in the form of Docker images are automatically promoted through the Open Catalog. In order to develop the platform, we collected requirements from research communities and identified several use case applications. For instance, plants classification, which developed into a more general module for image classification, is also used to classify conus marine snails, seeds, phytoplankton. The retinopathy application is developed to distinguish different levels of diabetic retinopathy from fundus retinal images. Satellite imagery application is to upscale low-resolution bands based on the information present in other bands. Massive online data streams to apply deep learning for intuition detection. In the project, we followed a leading interaction approach with a few applications to test the being-developed solutions and provide working examples to users. The Deep Framework triggered attention among data scientists and scientific communities, and in the meantime, more of external communities leveraged the framework. There are also 3 use cases which were added very recently as our contribution to fight the COVID-19 emergency on different fronts. Many of these applications can be found in our Open Catalog. Here you see the detailed architecture of the platform and various components used under the hood and their connection. Please check our poster for a better overview. You also find more details in the published article. Here, our summary. The Deep Framework provides services and facilities to machine learning deep learning practitioners with a set of tools and cloud services that cover the whole development cycle, from the model's creation, data processing, training, validation and testing, to the model's serving and sharing. Here you also find several important references and links, and I also want to mention that Deep as a Service training facility is promoted via the European Open Science Cloud portal. And with that, I want to thank you, and I also want to thank the sponsors of IEC 2020.